My name is Jose Perez Morales. I'm the VAB Element Manager for the Ground System Development and Operation Program here at KSC. I was born in Puerto Rico. I'm a civil structural engineer, been working for NASA for about 31 years now in August. So I've enjoyed tremendously my work at NASA. The VAB, the Vertical Assembly Building. The VAB was basically built for the Apollo program in the 1960s. Obviously, at that time, it was probably one of the tallest building and most basically volume type building in the world. The VAB, the main purpose of the VAB is to process the vehicle. Back in the Apollo program, there was a mobile launcher that was put inside the vehicle, inside the VAB, and then the vehicle was basically assembled on top of the mobile launcher. During the shuttle program, it was basically the same thing. The VAB has 4 bays. During the shuttle program, they used 2 of the bays to assemble the shuttle and get it ready to go into the pad for launch. For this new SLS program, basically we're modifying one of the high bays. It's called High Bay 3. It's one of the 4 high bays we got. And what we're doing is obviously taking the building and reconfiguring all the old platforms that were there. We basically demolish everything and we reconfigure the building for these new platforms that we just installed that are going to basically serve as a processing area. So when the pieces of the SLS rocket start arriving at the VAB in the transfer aisle, these pieces will be moving to High Bay 3 and basically be assembled on top of the mobile launcher. And as the rockets start growing in height, these platforms basically surround the vehicle so that the operators can work around and basically process and do all the connections that they need to do. Back in the shuttle days, what we used to do with the shuttle was basically assemble the shuttle on top of the mobile launcher platform and take it out to the pad for all kind of connections. And that took a very, very long time. It probably took more than 45 days at the launch pad because we live in Florida. Florida has a tremendous amount of changing weather. And because of the weather, it took so long. Now with this new program, we changed completely the whole dynamic of how we're going to process the vehicle. We basically went back to what Apollo used to do. Now we're going to assemble the vehicle inside the High Bay 3. We're going to do all the connections inside High Bay 3. And this is going to be obviously protected from the weather. Once the vehicle is ready, the goal is to take the vehicle out to the Pad B, which is where the launch is going to occur, do few connections over there, and in less than probably 7 days, we could have a launch of the vehicle. This is a very, very different dynamic than what we have for, obviously, for shuttle, because now we could be ready to go take the vehicle out when the weather conditions are favorable and when we know that we can launch the vehicle very quickly. At the VAB, obviously for the SLS, we decided to build the state-of-the-art platforms that are going to be used to process the SLS vehicle. One of the difference from these platforms than from any other platform we used in the past is that these platforms are very dynamic in the terms that they can move up 10 feet or move down 10 feet. That basically allow us to process or take into account any change of the shape of the vehicle. And instead of having to go and build a new platform and having to put a new platform at a different elevation, we could move these platforms up and down. Not only we could do that, but the platforms are designed so that if the vehicle changes its shapes at the elevation of the platform, there's what we call an insert, which is basically half of the platform that we could take out, we could modify, and reinstall on the platform. That way, if we were gonna, for example, if we were gonna have to process a commercial vehicle in the High Bay 3, we could do that very quickly by modifying the insert or modifying the elevation of the platforms and be adapted to whatever shape the vehicle has. Obviously, the vehicle will be assembled on top of the mobile launcher. With the platforms, obviously come all kind of facility type like connections. The platforms will provide all the power, all the pneumatics, all the compressed air, everything that the vehicle will need at the platform level or the mobile launcher will need in order to be connected to the platform. We included some additional special platforms for the top of the solid rocket booster that are very, very complex that will basically surround the cone of the solid rocket booster so that the operator can go and process the inside and do all the connections that are required in order to get the vehicle ready to go out to the pad. The platform has what we call some corbel rails, and basically the weight of the corbel rails was so much that the platform rotated only 2 degrees. It rotated only 2 degrees, and that was enough because the tolerances of the platform corbel rail and the rail pins to put past the pin was so tight, it was like 1/16 of an inch. So we needed to have that very straight, very precise. And once the platform rotated 2 degrees, that was it. We could not pin the platform, and it was very hard to do that. Basically, we designed 2 big, like 70-foot beams that went across the platform, one in the front, one in the back, and restrained those 2 corbel rails from having to rotate. We fixed them, we brought them up, we basically took the platforms down to the rails, and because the platform was completely straight, we were able to pin that platform almost immediately.